video will cover section 8.4 part B, and we're going to continue from where we left off last Wednesday. So what we did at the very end was to find the inverse of this matrix, right? And I know we were rushing. We're going to get to find the inverse of a 3 by 3 again with the next problem. So then we'll review that. Okay. So what we're going to do, this is and you have a couple of questions like that on your take-home exam to use the inverse method to solve the system. So the idea here is, imagine you have that equation that I always talk about for x is equal to 16. And you know that to solve it, you have to divide by 4, right? Or you multiply by 1/4, because 1/4 is the multiplicative inverse of it. Whatever we do to one side, we do it to the other, so we put times 1/4. And so we do that with the purpose of getting here 4 over 4, which is equal to 1, right? Because we want to isolate the x, or have the coefficient of the x being a 1, because we want to get that multiplicative identity right there. So this will be 16 over 4, which is 4. So 1x is equal to 4. So when we talk about systems of equations, we can do the exact same thing. And well, that's the basic idea. And you all know we cannot divide the matrices, so we're going to have to use the inverse instead of dividing. Okay. So before we do that, finding the inverse, we're going to create 3 matrices. The first one will be the coefficients of the system. So we will take the 1x, 0x, and then negative 2x. So that will be our first column. 1, 0, negative 2. Next column will be our y's. So we have negative 1, negative 2, and negative 3. And the third column will be 1, 1, 0. Then the next equation will be the variables. So in this case, our unknown variables are x, y, and z. And if we started writing our coefficients in x, y, and z order, we have to keep the same order when we write this matrix here, okay? And finally, matrix capital B is going to be the constants. So the numbers here after the equal sign. 2, 2, and 1/2. Like that. Okay, so what are we going to do with those 3 matrices? So I'm going to write it here in equations. So A times X, this matrix times this matrix is equal to this matrix, which is matrix B. Now, if we want to isolate X, just like we did here with the equation, we multiply by the multiplicative inverse. So the inverse of matrix A, just with notation, will be A inverse. Whatever we do to the left, we do to the right. So we multiply by A inverse here as well. And we do that because we want to associate these 2 together so that we can get the identity matrix. The one with the 1s on the main diagonal, 0s everywhere else. And what do you get when you multiply a matrix times its identity? So our identity is like a 1. So you get, well, the identity is like the 1. So you're going to get, like if you multiply 4 times 1, what do you get? 4. So if I multiply matrix X times identity, I get matrix X. So this is how we're going to find solutions to systems, by finding the inverse of the coefficient matrix and multiplying it times the constants. And of course, we're going to do an example of that. And here, what we have written here in this box is the same thing I just went over. So if you have a system and you can construct those matrices, then the unique solution to it will be the product of the inverse times the constants. So at the end, this is what it means. we're going to have here the inverse of matrix A times the constants. And this will be some numbers. And let's assume this is a 3 by 3 matrix. And this is, what are the dimensions of this matrix here? This one? How many rows? 3 by 1. Very good. So can we multiply these two matrices? Yes, these two numbers are the same. And the resultant matrix is going to be of what dimensions?
3 by 1.
3 by 1, right? The numbers on the outside. So we're going to have here something that will say x, y, and z is equal to, how many numbers are we going to get here? 3 by 1, so 3 rows, 1 column. And so the numbers that we obtain from there, those will be the solutions for x, y, and z. So that is the explanation of that method. Now let's do a problem. Are you guys okay writing this down? Yes?
Yes.
Okay, so we have a system here. So let's go ahead and construct the three matrices first. So matrix A is the coefficient matrix. So that will be 1, 0, -2, -1, -2, -3, 1, 1, 0. And then matrix X, capital X, will have just the variables, which are the letters, lowercase x, lowercase y, lowercase z. And then matrix capital B is the constants. So that is 2, 2, 1/2. Okay. Now, what we need, of course, is to find A inverse. Now, can we use the shortcut here? No, because it's not a 2 by 2. So we're going to have to do that stuff that you guys don't like, the row operations. So we copy matrix A, which is 1, 0, -2, -1, -2, -3. And please let me know if you catch a mistake, like as soon as you catch it, because then everything will be wrong if we don't correct it. And then what do I need to write down on the right side? You guys remember?
The 1, 0, 0, 0, 1, 0, 0, 0, 1.
Thank you. How do we call that one?
Multiplicative inverse?
Identity.
Identity.
Okay, so we're going to try to find the multiplicative inverse. So first of all, you already know we work by columns, right? And we already have the first column done. Well, almost. We have the leading one, we have the first 0. Now we need to make this -2 a 0. So we're going to use our leading row, which is row 1, because that's the one that contains the 1, times something plus R3. So if we want to make this -2 a 0, we need to add +2. So that's the additive inverse. So that's what we're going to use here, 2. Okay, so let's go ahead and copy R1 and R3. I'm sorry, R2. R1 and R2, because we're not changing anything. Okay. So then 2 times 0 is 0. -2. Wait a second. What am I doing wrong?
No, you're right.
No, I'm wrong. I need to multiply R1. Sorry.
Yeah.
So 2 times 1, 2. Okay, now it will work. -2, 0. Okay. And then 2 times -1 is -2. -3. Very good. 2 times 1 is 2 plus 0, 2. 2 times 1 is 2 plus 0, 2. 2 times 0 is 0 plus 0, 0. 2 times 0 is 0 plus 1, 1. All right, so we're done with the first column. Now we need to move to the second column, and before we make the zeros, what is it that we need to make? A 1. Very good. So that -2 needs to be a 1. So we're going to multiply R2 by the multiplicative inverse of -2. So we need it to be a +1. So we're going to need to multiply by something negative. And that negative will be negative half. Very good. So 0 times whatever is 0. And then we have the negative 2 here times negative 1/2, and that will be positive 1. And then we have a 1 times what? Negative 1/2. So that's negative 1/2. Then we have 0 times anything is 0. And then we have a 1 times negative 1/2. So that's negative 1. And finally we have 0 times that, so it's 0. Go ahead and copy rows 1 and 3, because we're not going to change anything to them yet. Okay, so now our leading row is the one that contains that 1, so it's R2. So we're going to use R2 to create a new R1 and to create a new R3. So let's copy R2. 0, 1, negative 1/2, 0, negative 1/2, and 0. Okay, so we gotta make this negative 1 into a 0. So what is the additive inverse of negative 1? 1. Very good. And then we need to make this negative 5 into a 0. So what is the additive inverse of negative 5? 5. All right, so that's what we're going to use. Now, when we're saying R2 times 1 plus R1, it's like we're just saying R2 plus R1, right? We're just adding one row plus the other. So let's do that right here. So 1 plus 0, negative 1 plus 1, 0. And then 1 minus 1/2, 1/2, positive. And then 1 plus 0, 1. And then 0 minus 1/2, negative. And then 0 plus 0, 0. Okay, so we're done there. Now we're going to multiply 5 times R2. 5 times 0 is 0, plus 0, 0. 5 times 1 is 5, minus 5, 0. And then 5 times negative 1/2. So that's negative 5/2. And then we're going to add them to 2. How many halves are in 2? 4. 4 halves. So what is that going to give me? Negative 1/2. Okay, and then 5 times 0, 0, plus 2, 2. And then 5 times negative 1/2. So that's again negative 5/2. Plus 0, negative 5/2. And then finally we have 5 times 0, that's 0, plus 1, 1. Okay, we're almost done. I promise. One more column to go. Okay, so on the third column, what is the first thing we must accomplish? The 1. Very good. So R3 times, start thinking about that number. We want to make this negative 1/2 equal to a 1. So what do I need to multiply R3?
Negative. No, positive.
Negative, because we want negative times negative, positive. So negative 2. So let's do that. 0 times negative 2, 0. 0 times negative 2, 0 again. And then negative 1/2 times negative 2 is 1. And then we have 2 times negative 2, 0 times, not plus.
Oh.
So 2 times negative 2, negative 4. And then negative 2 times that one. So that's going to be negative 5/2 times negative 2. So that's going to be positive 10 over 2, which is 5. And then negative 2 times 1, negative 2. Okay, so let's copy R1 and R2. Okay, now you guys know that we're going to have to make those two fractions zeros. So this 1/2 needs to be a 0, and this negative 1/2 needs to be a 0 as well. So now our leading row is R3, because that's the one that contains the 1, the leading row. So we're going to say R3 times something plus R1, and then we're also going to say R3 times something plus R2. So let's go ahead and copy. Let's copy the leading row, which is 0, 0, 1, -4, 5, and -2. So that's what we're going to be multiplying by something. So this positive 1/2, we want it to be a 0, so the additive inverse is -1/2. And this -1/2, the additive inverse is positive 1/2. So those are the constants we will use. Okay, now good news is that once you're done, if you have done everything in order, you don't have to do anything to the first two columns. They're not going to change. So we can just copy them. And then we also know that if we chose these numbers correctly, right, these two are going to turn into zeros. Okay, so now we just have to worry about the right side. So let's do that. Let's do this top row first. So -1/2 times -4. I'm going to write it down because in my previous class I did it wrong. So -1/2 times -4 is going to be positive 4/2, which is 2. And then we're going to add a 1, right? So what is 2 plus 1? 3. Now we're going to have -1/2 times 5. So that is -5/2. And then we're going to add that number. So plus -1/2. And that will be -6/2, which is -3. Okay. And then we're going to multiply. We're going to multiply -1/2 times -2. So -1/2 times -2 is equal to positive 2/2, which is 1. And that 1 we added to 0. So that is 1. Okay, now we're going to use positive 1/2 times -4, so that will be -4/2. And then we're going to, which is -2, right? I'm doing this. Positive 1/2 times -4. That's very good, right? So that's -2, and then we add it to 0. So what would that be? -2 plus 0? -2. Then it's 1/2 times 5. Jeremy, look over here. So that's 5/2 plus -1/2. So that is how many halves?
4.
Which is 2. And then the last one, 1/2 times -2, so that is -1 plus 0, -1. And that's it. That is it. Now, let me show you guys how you can check your work on the calculator. Do you guys have a calculator? If you don't, go grab one, please.
No, you got me the paper.
I said I got it. So, So, yes, you do have to show me all your work on your take-home exam if you want the points. If you don't show me your work, no points. So, with the calculator, you will check. So, let me show you how. Some of you might remember from Algebra 2. So, let's enter a 3x3 matrix. So, you press the button next to 9, and then you select the one that looks like a matrix, the two brackets, and you see a 3x3 right there. What's going on? You check that you want 3 rows, 3 columns. You're able to change it there in case you want a matrix with different dimensions. And then go ahead and enter your original matrix. The one from the system. May I borrow your paper? So this was 1. Use the negative symbol, the one inside parentheses. Don't use the minus.
You said that one.
These are zeros. I did that one with zero. This next one is zero.
Yeah. We're going to put a negative.
Oh, thank you.
You guys, I'm going to suggest that when you are taking your test and you're checking your answers, you double check that you're entering correctly on the calculator, okay? So once you have entered your matrix, you exit with the arrows to the right, to the right, to the right. And then you're going to select the caret symbol for exponent. And then the little box for the exponent will open, and you will enter a negative 1.
We got the wrong answer.
No way.
I'm just kidding.
I know it's right because I just taught this lesson 2 hours ago. Okay, so yes, that's how you would check. Could you find the inverse of a 2x2 on the calculator? Of course, absolutely. Could you find an inverse of a 5x4? No, only square matrices have inverses.
Oh.
Yeah. Okay, so let's go back here, and now what we do is we're supposed to solve the system, right? So what we need to do is solve that equation that I was talking about on the previous slide, the one that says that x will be a inverse times the constant matrix. So to find a solution to the system, we will need the inverse here. Times the constant matrix. What were the constants from the top?
2, 2, and 1/2.
2, 2, and 1/2?
Yeah.
Okay. Thank you.
You're very well.
Okay, so we multiply that. And can we multiply first? Yes. 3 by 3, 3 by 1. The two numbers in the middle are equal. So our answer will give us, what are the dimensions of our answer? Remember the numbers on the outside, right here, a 3 by 1. 3 by 1. And so let's do this multiplication quickly.
What?
That's where they're going to go in.
Yeah.
It's just so you know you have to add them. So we take first row times the column. So 3 times 2, 6. Negative 3 times 2, negative 6.
1/2.
Plus 1/2. There you go. So then when we write our answer here, that's 0, so it will be 1/2. All right, now you guys find the other two.
Can we write them for a card?
Sure. Go ahead. You can do the third one.
Hey, your work.
You gotta show your work. Oh, no card. No work, no card.
That's not how you do math.
Yes. In my head.
I only have 2 cards. Ooh, they're very good cards. Ooh.
What? That's my first card.
Oh, well, you gotta find yourself a partner.
Yeah, I got Isaac.
You got cards too? Okay.
I just see we've been hustling the whole
All right.
time. Alright, bro.
Amy, put your phone away. Or we'll take it for the whole weekend.
Oh.
Yeah. Why do you think I'm so happy?
It's like 50-50.
No!
No, what?
We're looking!
No, I was closing my eyes.
Okay.
You're in lady.
Oh no.
Which one's which?
Here, pick one.
Where the
You're good at
You good?
So you can get one.
No. What's the other card? What's the other card?
Oh, you can't know anymore.
This is 10 now? What?
Calculator.
What do you mean a calculator? No.
Wait, can I solve it first?
This is a minus
Third card?
8. 5 times 2 is?
No.
Yeah. You want to play that?
-4 times 2 is -8.
The first one or the second one?
The first with the first, the second with the second, the third with the third.
Oh.
Alright. Correct it, because this is a really good card. I don't know.
It's an ace, isn't it? Yeah, it's an ace.
Oh, it's an ace. Is it close? Is it close?
I cannot disclose that.
Not yet.
You know what's actually gonna go
Plus 10. Plus 10. No! Oh, yeah, that's right. Here you go. That was my last card.
Ace.
Is this
Ace.
a- what?
Ace is diamond.
It was an ace.
Yeah.
Okay, so what does this mean? It means
Wait,
that.
miss, but I did it wrong. I did it wrong. I forgot the over one.
Alright, guys.
The definition.
Let's go to the next slide, please. Okay, so a cryptogram is a message. Actually, I need so that no one other than the intended recipient can understand it. And so remember the little story I told you about World War II, right? And so yes, you cannot question this. This is a real thing. That's how World War II ended. Huh?
You go up.
Yes.
You can see the
And so from last class, I showed you how to encode a message, right? So we have to have a key. The sender and the recipient have to agree on a key matrix. And then they would use that to encode and decode. So to code, you multiply the key times the message. And then you obtain the encoded message. Now, for the recipient to decode it, it's like opening a box. So they have to undo what was done.
We can't do right.
Very nice, William, yes. Since there's no division in matrices, we have to use multiply by the inverse. Very nice. So let's go ahead and we're not going to decode the previous message because we already know what it is. So I do have a surprise message for you here.
Aww.
Yes. So first we need to find the inverse of k. So let's see if you guys remember how. You need 1 over the determinant. The determinant is 2 times negative 2 times 4 is -8. And then 3 times -3, that's what?
-9.
Wait, are you sure you're doing it right? Don't you have to switch something or something?
Yeah.
Oh, there's a minus. Yes, yes.
Yeah.
There's a minus. I'm sorry. So it is -8 minus -9. That was the problem. And then that's what we do. We switch places. The -2 and the 4 switch places.
Oh.
Wait, then why'd you have to? Oh.
And then the -3 turns into positive, and the +3 turns into negative. Because we have to multiply by this constant, the reciprocal of the determinant. And remember I told you, if the determinant was 0, then there will be no inverse.
Oh, right.
So therefore, there will be, you cannot use it. The matrix is not invertible, therefore it is singular, and you can't use it as a key. So, if we compute this number here, it's just going to be 1 over -8 plus 9, which will be 1 over -1, which is?
Negative.
I'm sorry, positive
Oh,
1.
yeah, positive.
Oh.
So it's just 1. So I love when we just multiply by 1. That's perfect. We don't need to do anything. So the inverse for the key inverse is just going to be that 4, 3, -3, and -2. So now, how are we going to decode the message that I wrote for you? It's a very nice one. So you're going to have to multiply, stop talking, key inverse times the message that I wrote for you. And it is going to have to be like a 2×8 matrix. So for example, every 2 numbers is 1 column. So like -72, 101. And then -10, 15. -71, 99. And what I want you to do is, with your partner, together with your partner. Well, one of you can be reading the numbers. The other one could be typing them on the calculator. I'm going to show you how to do multiplication, so you can check all of your answers. Okay, so on your calculator, guys, you will, I'm just going to clear my screen for now. What's going on? Or not. Okay, so you're going to enter a 2×2 matrix first, which will be the key. What is the key? Can you tell me the key, Chris?
4.
Positive 4?
Yeah.
And then positive 3?
Yes, -3. -3.
The top?
No, the bottom.
The bottom is negative. Okay, -3 and the other one?
-2.
Okay, thank you. -2. Okay, then you exit, press the multiplication button, and you're going to enter the other matrix, which is going to be a 2×8, I think. So the key, the shortcut for that is you select the 3×3. Please pay attention to the board. Select the 3×3.
Process.
And then you're going to change here the rows to 2 and the columns to 8. Oops.
Yeah.
You can press tab to move to the next. Okay.
We're done.
And then you guys have to enter all the numbers. Yes. So those are the numbers you have to enter on the calculator. And then once you do that, you are going to translate them into letters. You guys finished? Okay.